This is Algebra 2, lesson 7.1. Doing nth roots. That's how you read that, as nth roots of rational or and rational exponents. We're evaluating nth roots using radical notation and rational exponent notation. That's a whole lot easier than it sounds. Then we're going to use them in real life problems beginning on page 401. We got a couple of definitions. First one is the nth root of a. That's how you'd read that. The nth root of a. For an integer n that's greater than 1, that means something bigger than 1. So we're talking about positive numbers here. If b raised to the n power, or b to the nth, is equal to a, then b is an nth root of a. Now typically this looks like a whole bunch of gibberish, but typically we've been talking about this. We said, again, that undoing x squared, we know how to undo that. We take the square root of it, and undoing something to the square root, we know to square it. Um, the reason I tell you that is because now we're not only looking, anytime anytime you draw this symbol right here, the square root symbol, you call it the square root for a reason, because it's the square root, how many numbers or what number times itself. We're going to be dealing with roots that are different than the number 2. You don't have to write in 2 when you're talking about a square root, but when you're talking about the cube root of something, you're going to put a 3. When you're talking about the 4th root and 5th root and you keep going, you just put it like that. That just means what number times itself that many times. So um, if you multiply the number 2 times itself, 2 times 2 times 2, 3 times, you get the number 8. So the cube root of the number 8 is 2. Again, I mentioned to you guys yesterday that those numbers will start to be familiar to you. And typically the numbers will be very small. You don't have to get very large with them. The index of a radical, the integer n, in the expression, now this is the nth root of a. That's how you read that, where n is greater than 1. So the index is when it, again, is a positive number, something I'm talking about greater than 1. That's the index. So when I ask you what is the index of the cube root of 8, this is the index. Which root are you talking about? Let n be an integer, so it's real nth roots. Let n be an integer greater than 1, and let a be a real number. So if n is odd, okay, so right here, if it's an odd number, so if you're talking about an odd root, think about what's going on with an odd root. That means it's multiplying by itself an odd amount of times. So think about just comparing 2 and 3. 2 is even and 3 is odd. When you're talking about even numbers times themselves, or an even when it's times itself, an even number of times, there'll be 2 of them. When it's odd like this, where the nth root of a is a to the 1 divided by n, or 1 over n. When n is even and it's greater than 0, that means it's positive. Anytime you see that word, that symbol greater than 0 like that, you're not talking about any negative numbers right here. Then it's both positive and negative a to the 1 over n, not just positive like this one. It's both positive and negative a to the 1 over n. So it has 2 real roots. And if it's even, um, then a has 1 nth root. Excuse me, if n is even and a is equal to 0. So we're talking about 3 different scenarios. Let me just highlight the different scenarios real quick. Um, Greater than 0 for this one, odd for this one. These two are both even. Greater than 0 equals to 0 right here. So it's going to be 0. So if a's value, talking about, it doesn't matter how many times you multiply 0 times itself, or it's going to be the number 0. And then again, if it's even, but in this situation it's less than 0. So this is talking about negative numbers. There's no real nth roots. Okay, and we know that there's no real things for the same reason that there's the square root of -4. We know that there is no real number that gives you a square root of a negative number. We talked about complex numbers where we multiplied that by the imaginary number I to where we can mathematically work it, but there's no real number we can multiply by itself to give you a -4. There is, however, a cube root of negative 8. Think about what that means real quick. What would the cube root of negative 8 be? Negative 2. And again, look at there's four scenarios up here. 1, 2, 3, and 4. If we look at them like this. 1, 2, 3, and 4. There's four scenarios. There's only one of those four scenarios deals with an odd index, the first one. See, it says if n is odd, then it has one real root. It can be a negative number because you can multiply negative 2 times negative 2 times negative 2. You can do it 3 times and actually get a real number, negative 8. You do not need an imaginary number in that case. Example number 1 is finding the indicated real nth roots of a. N is equal to 3 and a is equal to 64. So right away, since the index is 3, it will have one real cube root, no matter if 64 was positive or negative. It does not matter. Okay. So you would rewrite this as the cube root of 64. That's how you'd write that. The cube root of 64. Because 4 to the third power is equal to 64, you can rewrite it as the cube root of 64, which is equal to 4, or here's the notation, 64 to the 1/3 power. Notice that's the same thing. That's why it says or. That's the same thing as the cube root of 64. And we'll start rewriting them in that fashion, especially when we're dealing with the elevator rule with negative values. For B, because n is 4, so now this one was an odd number. It had 1. This one is an even number, and it has a positive number. So it's going to have two real roots. So n is equal to 4, and because n is equal to 4 is even, and a is equal to 21, which is greater than 0, 81 has two real roots. So we're going to come over two real numbers. Because 3, when you raise it to the fourth power, is equal to 81, and negative 3 raised to the fourth power is equal to 81, you could write it as both positive and negative for the cube root of 81, which is both positive and negative 3, or positive and negative 81 to the 1/4 power, which is both positive and negative 3. On the back, everybody. Let's try this one. This is the index, or n in this case, is 5, and the a value is negative 3. Find the indicated nth roots of a. So rewrite it as a radical. You have to multiply a number times itself 5 times. So the number cannot be very big to get to the number 32. We'll deal typically with small numbers when we're talking about this. So we would rewrite this as the fifth root, that's where the index goes, the fifth root of negative 32. Now, when we dealt with this before, had this just said the square root, we would know that there's no real number that multiplies by itself, so we would have to multiply it by I. But since we're talking about the fifth root, since that's an odd number, there is a real number we can multiply by itself 5 times. And just start thinking to yourself real quick. If you go even as high as the number 3, if you multiply 3 times itself, so 3 times 3 is 9, that's 2, times 3 more is 27, times 3 more is 81. So when you do 3 to the fourth power, you already jump all the way up to 81. So it can't even be as big as the number 3. Again, you'll get familiar with 2 and 3 and 4. You'll get familiar with counting by those numbers when you're multiplying them by itself. But in this case, it is negative 2 in this case. Negative 2. And that's the only real number that goes with it, negative 2. Positive 2 does not work here. Try this one. Rewrite it in radical form, and then give the answers that go with it. The answer or answers. Again, these problems don't take very long. And again, you're talking about cube root. The other one was the fifth root. So anytime you're talking about any root that's not the square root, anyone that's not 2, write it with the index. Put it before you even write the number where you don't forget. The cube root of 64. So what number, when you multiply it by itself 3 times, is going to give you the number 64? So think real quick of small numbers, because if let's just think of the number 5. If you do 5 times itself twice, that's 25. When you multiply 25 times 5 3 times, that gives you 125. Look how fast that number jumps up. So it can't even be as big as the number 5. We did a minute ago 3 times itself 3 times, and we got to 27. So we know it's bigger than 3. This has to be positive 4. And also, since I said and also, since our index is 3, since that's an odd number we said a minute ago, there is no there is no negative value associated with this one. Because if you multiply this one's not both positive and negative 4. That doesn't work. Because if you do negative 4 times negative 4, you get positive 16, which would be right. But then when you multiply it by negative 4 again, it gives you negative 64, which is not what's under the radical. So only 4 in this case works, not positive 4. If you put not negative 4, if you put negative 4, it would be incorrect. Okay, and then you have 2 checkpoint problems. It says find the nth root 3, or the index 3 up 343. Again, this is one of those numbers that you'll get to real quickly. It looks like a big number, but it's really not. What number times itself 3 times is 343? We would rewrite it like that. We would say the cube root of 343. Okay, so again, let's use the number 5 as our baseline. 5 times itself twice is 25. Times itself one more time is 125. So we know we got to go bigger than 5. Okay, if we do 6 times itself twice is 36. Times itself one more time is 200 and oh, it's 216. So we got to go a little bit bigger than that. Probably 7 is going to be right for this one. You with these. Again, 7 is what it's going to be, and it took me a second to come up with this one. But you get more familiar with these as you do them. Typically, you use numbers that are smaller than 7. But the cube root of 343 is 7. And again, it is not negative 7. Because if you do times negative 7, if you do it one more time, you're going to get a negative value, which is not positive 343, 7. This one right here, the fourth root of 256. So now it's something times itself 4 times. Again, if you use 5, that's just one you get comfortable using. 5 times 5 is 25, times 5 is 125, times 5 one more time is 625. That's way bigger than we want to be. If you use 4, however, 4 times itself 4 times is 256. And it's both positive and negative. It's both positive and negative 4. Notice the difference between number 1 and number 2. Why number 2 is both positive and negative? Because it is an odd index versus an even index. So rational exponents, let a to the 1 over n be an nth root of a, and let n be m be a positive integer. So that's what we're going with. Anytime you have a raised to a fraction, it can be rewritten the way it's written in the middle right there. It can be rewritten as a to the 1 over whatever this is. So that's 1 over that. And both of them are raised to the m power. Typically, the easiest way to do this, however, is to ignore this middle part. Most of us, when we see something raised to a fraction like this, when we see something raised to a fraction, we just jump right to this step because this is the workable step. Whatever the bottom number is in the fraction is the index. whatever the top number is in a fraction is what you raise it to after you do what's inside the parentheses. So it becomes in parentheses. What's different about the second one is it's raised to a negative value. Remember, anytime something's raised to a negative value, it has to ride the elevator. If it's at the top of the fraction, it goes down. If it's at the bottom of the fraction, it goes up. And that's what this says. Again, this is the step most of us usually skip. We usually go right from this step to this step here. We go right to this. 1 over that bottom number in the fraction is the index. The top number is what you multiply it by. Okay, when you see that with some numbers, it makes a little bit better sense. 25 to the 3/2 power. Okay, we're going to rewrite that again as a radical 25. This is the index, so 2. This is what it's raised to after you do what's inside parentheses. So you're saying a square root, and again, there's no reason to write that 2 right there. I'm just doing it since that's what we're writing numbers that aren't 2 right now. It's not wrong to put 2. So it's saying the square root of 25, which we know is the number 5, and then 5 to the 3rd power, which is 125. So the square root of 25 to the 3rd is 5 to the 3rd, which is 125. The second one is 27 to the negative 2/3 power. Again, the negative goes first. This makes it ride the elevator. So it becomes 1 over 27 to the 2/3. Now you do it like that. 1 over the radical 27 goes, the radicand goes under the radical 27. This is the index, so it's the 3rd root of 27, and the 2 is what you raise it to after the fact. So it looks like this: 1 over the cube root of 27 squared. The cube root of 27, 3 times 3 is 9, times 3 more is 27. So it's 1 over 3 squared, which is 1 over 9. On the back, one more time. Do 16 to the 5 over 2. First, rewrite it in radical form, and then find whatever root it tells you to find, and then raise it to that power however many times you have to do it. Again, the bottom number is the index, this one. So it's the square root of 16. The top number is what you raise it to after you take the square root of 16. What number times itself is 16? 4. So it's 4 to the 5th power. 4 times 4 is 16. Times 4 is 64. Times 4 is 256. Times 4 one more time, 1024, is 1024. And I should know that one. You actually used to that one. And one more, everybody. 64 to the negative 2/3 power. Again, remember what has to go first. What has to happen first. Then rewrite it in radical form. If you're getting stuck with the cube root, remember, think small, not big. You only got to get to the number 64. Again, the negative takes precedent. It becomes 1 over 64 to the 2/3. That's what has to happen first. I got rid of the negative exponent. Then it's rewritten as 1 over the radical 64. This is the root or the index. And the 2 is what you raise it to after the fact. So 1 over 64, the cube root of that, 4 times itself twice is 16 times itself one more time is 64. So it's 4, and 4 squared is 1 over 16 is what it winds up being. 1 over 16. Right there.